Hey guys, Mr. Sonnenberg here. Today we're going to be talking about how structures fail. It's Social Science 7 students, and this is Structures and Forces. It's going to be topic 5 in your textbook for study purposes. The general outcome that we'll be meeting today is I can identify points of failure in natural and manufactured structure or buildings. So examples are tree branches snapping in ice storm or bridges collapsing due to overloading. Okay, we're going to discuss what kind of forces are placed on these structures and what causes them to fail. So we have to remember or first think about the fact that we typically deal or think about at first is manufactured structures, man-made structures failing, but we have to remember that natural structures fail as well. Trees snap in the wind. I was driving to Whitefish, Montana the past summer, and we were driving through, and we got to this one place called Frank. It's called the Frank Slide, and what happened was there was Turtle Mountain on the one side of the road, and well, there was no road at the time, but then there was the town of Frank, and what actually happened was part of the mountain, Turtle Mountain, sheared off, and it came collapsing down. Gravity pulled it down, and it wiped out majority of the town, and it actually covered the town in huge chunks of rock. So now it's actually a tourist site because it almost became obviously like a ghost town, because the rocks and that natural structure, that mountain, Turtle Mountain, when it sheared off and all those rocks came crashing down, it covered the town or the majority of it. But then we also have manufactured structures, and the one that I would say most recently is the mall in Toronto. The parkade on the upper portion of the mall, the steel I-beams were actually, they were corroded and they gave way due to metal fatigue, and it collapsed in towards the mall from the parkade, which was quite scary. But so what happens with these structures failing is there's always going to be forces acting on them, and that's what's going to cause them to fail. So remember, we talked about the two types of forces, one being external. We have live loads, things like the wind, or maybe us sitting in a seat, or vehicles parking on a parkade or driving on a road. Those are live loads because they're not always acting consistently on that particular structure. And then there's dead loads as well, which is another external force. And those dead loads are maybe the object's own weight or mass, and it actually can hold its own weight and its ability to support itself. And then also things such as gravity as well are dead loads. So, and then when we have these loads applied, these external forces applied, then we have internal forces that are acting. So we have our compression and our tension and our torsion and our and those type of forces that are actually binded together, and they're holding the structure together, and they're attracted, the particles are, but at some points then they just cannot hold on any farther and the structure fails. So that's what we're talking about today. So sometimes the structure can fail if the force that's being applied to it is too strong for the actual design. And also sometimes you might just get, they say, I don't know if anyone's watched NHL games or even those Rock'em Don Cherry Rock'em Sock'em videos, they always show the glass breaking. And sometimes they say it's a pressure point, so it's a structural failure. And sometimes they say there's a point, you don't have to hit it hard and the glass can shatter. I actually did that when I was in atom hockey, and I was just a little guy. And we were playing in the West Edmonton Mall tournament, and I took a slap shot from just inside the blue line over the net. And when I'm atom age, I could shoot the puck, but it wasn't that hard. And it hit the glass, and it shattered the glass because it must have hit a pressure point, a vulnerable part of the structure, and then the glass, it failed. So that was interesting, but that was a manufactured structure, and it failed, but it was the force that was applied, and now I didn't apply a lot of force, I just might have hit a vulnerable part of the glass. So material failure, when we talk about the different types of material, how do these materials fail? Well, the first way they can do it is shear. And shear failure actually, if we take a look here, remember shear is moving in different directions. So possibly one is moving in one direction and the other, and it shears. So we get these two pieces separating. We also had these pieces must have sheared off and broke off as well. So it's a minor weaknesses in the material that cause failure because the particles move farther apart and are less attracted to one another. So that concept that if I was to hold on to a person across from me in the desk and we were to hold hands and we were to try to back up, eventually we would slip and we would fall backwards. Both of us, our structure would fail. Okay. And a lot of the shear force can be caused by compression. So if I had a bridge, for example, okay, right here, and I just have a support here and a support here, and I have the car driving on it. Oh, that's a terrible car. Well, it's a delivery van. We got a delivery van coming with a pointy nose. Maybe we'll draw some whiskers on there and maybe an eye, and that's a car. So anyways, what's happening is it's driving, but what's going to happen to this structure actually is it's going to compress down. We're going to see this compression force right here. So what happens then, if there's too much compression and the force is too great, then it's going to crack and then it's going to crumble down. Okay, so that is shear force. That's one of the material failures. Another material failure we can look at is bending or buckling. Okay, and that's right here. So compression can also cause that compression, but if we compress a material, okay, so in this example we had compression forces pointing here, okay, and it caused it to buckle or bend. Same thing, we're applying compression forces and we can see them down here, and we get this bow in the structure. Okay, so when things bend or buckle though, we think of maybe a pop can. So if I had my pop can here, and excuse my drawing, I'm quite poor. I had my pop can, and then I took my little Lego feet and I stepped on it, okay, with my shoe and applied force down here. It's going to compress it, and then what I'm going to be left with is something like this, and it's compressed. Okay, because I squished it down and I compressed it and it buckled. Okay, so that's one way we can get this force. Okay, so sometimes what they do is to prevent reinforcements is they add stringers or ribs, and they're used to strengthen a structure. So stringers we can put along the side, okay, to support the structure, just like stairs. Stairs actually have stringers. So when I built my steps outside, I actually had an area, I'll just draw it up here, but it looked like such, and it came down and then it went out, pointed up, came up the side of the stairs, but it actually had metal stringers in it, okay, that actually would go like such for my steps. And then these stringers, then I could attach the planks or the boards across them, and then I could create my steps. But these stringers added extra support for the steps. And then lastly, we have torsion. So material failure caused by torsion. Remember, torsion is twisting. And when we twist, what happens is the particles within that substance become closer together. So when we did the test and we squeezed the water into the bucket and we thought we had it all out, then we twisted, we actually got quite a bit more water out of that towel, that wet towel, because the particles were forced closer together, thus pushing out any other substances that they had soaked up and absorbed. So this twisting, this torsion force, this twisting force can actually cause material failure as well. When sections of material they slide past each other, then it can crack and break in two, and we get that shear, okay, where we can get that cracking. But if we twist too much, okay, then what happens is that structure can break, and it's tough to put back together as it's broke off at an angle. Okay, even when things twist, sometimes we can't get them back. So if something twists, it's tough to get it back to its correct position. I know I dented the bumper on my truck. I didn't. My father-in-law did. And it twisted it, and so we wanted to twist it back, but we just couldn't get it to the correct shape. So went driving around with a bumper that wasn't exactly straight. It was close enough, but it lost its shape. But that was due to twisting force that caused the particular material to fail. So anyways, that is material failure for the most part. Okay, just a quick breeze through, but a lot of structures are, we think about these material failure in our everyday lives, and some structures, both natural and manufactured, eventually are going to break down and they're going to fail at some point. So what we typically do is we make sure we're constantly adding and cleaning them and patching them up, adding supports when needed to ensure that the structure doesn't fail. But there's other structures that are consistently getting used, and they have a lot of stress being placed on them, such as roads and sidewalks, and we're continually having to fix roads. Every spring they have to come out and they have to patch up the roads, fix the roads. We see highway construction all the time. Sidewalks are being poured because those structures that are continually being or having stresses opposed on them are actually going to fail much faster, and so we have to repair them. But every time we repair something or we see a mistake or a failure in a structure, the designers can actually use that information and they can actually rebuild and understand areas that they can make the particular structure and material even better. So we can learn a lot from some of these mistakes, and we can make adjustments and then ensure that these structures don't fail as fast or at all. So anyways, that is structures or failure in structures. I hope this has helped. Bring your questions to the class, and thanks for viewing and tuning in, guys. Okay, bye.